When you come to Boeing and our service reps, they know the aircraft. They don't have to call anybody else to get that information because they already know it.
I'm Teresa Hitchens with Breaking Defense, and I'm here today with the Air Force Lifecycle Management Center, and I'm going to be talking a little bit about the technologies that they are putting out there to try to modernize maintenance, speed, parts to the aircraft and other systems, and hopefully we'll learn a little bit today also about 3D printing.
My name is Kyle Singer. I'm a contractor for the Lifecycle Management Center, working in partnership with EZP, the Product Support Engineering, and the RSO, the Rapid Sustainment Office, contracted through the University of Dayton Research Institute to qualify these new technologies.
So can you talk to me a little bit about what you're working on with additive manufacturing? This is an area of intense interest within the Air Force and within industry. So there's a lot of excitement around additive manufacturing. Dr. Roper mentioned it yesterday in his talk, and he actually called out the University of Dayton. So I'd just be interested to know where you are with that and what your goals are for going forward.
Excellent. That's easy. Dr. Roper has been very interested and a big supporter of what we're doing, obviously. So what we started with was we had to qualify and transition the technology into the Air Force. And in order to build aircraft parts additively, you have to do material characterization. So we know exactly what kind of material properties we get out of the part. And we know that every single time we print the part, it has to be exactly the same. So we have to do repeatability studies on it as well. There's a lot more that goes into it than that, the airworthiness certification and that kind of stuff. But what we're started with were structural but non-critical. So if there is a failure, you don't have an aircraft crash, basically. But still some structural components that have to hold legitimate loads. And so what we've done is we are teaching the Air Force how to do this by printing the parts and getting them out in the Air Force. In doing that, we've learned how to and how not to use additive manufacturing. And so we've written design rule books and software guides to teach the Air Force how to do it. We've already rewritten and published TOs.
What's TO?
A technical order for the flight line maintainers, for them and the depots to operate from so they can know how to use the machines. We have training centers set up to teach technicians how to run the machines. And we have training courses also set up for the Air Force engineers to teach them how to design something for additive. There's very specific design rules you have to follow when you design something specifically for additive manufacturing.
So Travis Air Force Base recently put out a press release about the new printer that they've received, and that their first qualified couple of engineers who are printing, they were very excited. And just can you tell me, is that something you're hoping to, or the Air Force is hoping to replicate around at different depots, or how will that work?
Absolutely. So the goal is, like I said, we're learning how to do it so that we can teach the Air Force how to do it. Starting at Wright Pat, we have all the machines to do the qualification work, but we also have 6 machines already set up down at Warner Robins, Georgia, which is one of the depots. And so they are now currently printing aircraft parts for their own depot lines. We have machines staged and getting set up at Tinker and at Hill, the depot lines out there. So in the next couple of years, we're going to have machines set up at all the depot facilities so they can print their own parts on demand on the depot lines. Years down the road from there, the goal is to have more bases with that same capability out in the field.
One last question. I'm interested in engines and in the use of 3D printing for engines. When I was at the Paris Air Show this year, I noticed that some of the engine companies, were looking at very high temperature materials to do like engine nozzles and things, and I would think that that would be really hard because of the temperatures and the stresses that would be put on those parts. And I just wondered if that's something that you're also experimenting with.
As of right now, we're not doing engine parts. It is certainly something that we are looking into. We're not afraid to do it necessarily, but as of right now, the OEMs who produce the engines, they're the ones that are doing specific parts for the engines.
OEMs means?
The original equipment manufacturer. So those are the guys that are working that stuff. We are doing replacement parts that are stuff that's replaced on the flight lines.
Okay.
We have looked into high temperature nickel alloys, which is an Inconel.
Yeah.
And this engine here on the table is one of those things that we've used to showcase that, yes. That's a high temperature nickel alloy right there. That's a 3D printed turbine engine.
It's a turbine?
It is, just a microturbine engine. So that is something that we have played with as a proof of concept and a technology demonstrator, just to show that it can be done and you can run really high heat, high stress engine components. So this thing spins at 70,000 RPMs at 2,000 degrees and it hangs on just fine.
That's great. And this is just, I mean, obviously it's an experimental model, right?
Well, it's microturbine engines, so these kind of things could be used in munition systems, UAVs, or auxiliary power units, APUs, on aircraft.
Oh, really?
So
what about space? Spacecraft?
We have not looked into any space stuff yet. All the stuff this engine is obviously air breathing, so it wouldn't get up into space, but we have not looked into rocket.
Well, that's great. I appreciate you taking the time and trouble today, Kyle. This is really fascinating, and thank you. And have a nice day, readers.